As we know already, 8255 working in two operating modes, that are BSR mode and IO mode. BSR mode mainly controls the port C information, that only used for controlling of C port bits. Mainly C port bits are used for controlling as well as status signals of the other ports information. The other ports are port A and port B. Then second, IO mode. The IO mode nothing but input output mode. It is subdivided into three modes: mode 0, mode 1, mode 2. The mode 0 known as simple IO mode, mode 1 known as strobe or handshake IO mode, third one bidirectional IO mode. These are the three sub modes of operation under the IO mode operation. Now we will see simple IO mode operation. Simple mode IO operation, and second one strobed IO operation, third one bidirectional IO operation, or simply mode 0, mode 1, mode 2 operations. Now simple IO operation or mode 0 operation. In simple mode IO operation, the data transmitted from the 8086 processor to IO device through the port A or port B or port C. When data transmitted through the port A or port B, port C, there is no interrupts allowed and there is no acknowledgement signals used in simple IO mode. That's why directly we started discussion of IO mode 1 operation. We already know the modes, either BSR mode, IO mode, decided by the control word which is received from the 8086 processor through the data bus. Now see in the given diagram, IO mode 1 operation. In IO mode, the data receiving D7, D0 bits, D0 to D7 bits. We already know how mode will be identified based on D7 bit. Yeah, this is D7 bit. The D7 bit is 1, indicating IO mode operation. So next D5, D6 bits will decide the sub mode operation. D6, D5. 0, 1 indicating mode 1 operation. Mode 1 means group A selected for operation. Group A means port A selected for operation, port C selected for operation. Now this is the example for mode 1. port A selected. Port A selected. Now when port A selected, D6, D5, 01. 01 indicating mode 1. Mode 1 means strobed IO mode or handshaking mode. Why they started IO mode 1? Because here there is a acknowledgement signals are passed between 8086 processor and the input output device. Now we will start the process how 8086 processor will read or write nothing but input output from the IO device. In this given example, they are explained input operation performed by 8086 processor. Input means reading data from the input output device. This example 8086 processor reads data from the input output device. Now reading input data by the 8086 processor through the port A. The below one given same like port B. Now we will see first one how port A is used to transmit data from IO device to the 8086 processor. There is a sequence of steps given to read data from IO device to the 8086 processor in IO mode 1 operation. The first step, IO device place the data on the port bit or port register. After placing 8-bit data on the port register, immediately it will use a strobe signal to the port A. If you observe STB signal, STB is nothing but strobe acknowledgement of port A. Strobe signal is an acknowledgement signal of port A. First data is placed on the port A register bits, then immediately it will send one strobe signal to the 8255 port A. Once acknowledgement given through the STBA, now observe that STBA signal is received through the port C register. That's why port C used for status or control signals. Once strobe signal is given, means the 8255 reads port A bits data. Now data is presented in port A0 to port A7 bits. Now here data is presented. Then second step, immediately after receiving data by 8255 interface unit, it will give an acknowledgement signal to the input output device called input buffer full acknowledgement of port A. IBF given as input buffer full acknowledgement of port A. This will be given to the IO device. The meaning of this one is 8255 sending acknowledgement signal to the IO device. Yes, I received your data through the port A. Once data received by 8255A through port A, now data is with the port A. But who is needed the data? 8086 processor. Then third step, immediately port A using PC3 bit, it will give one interrupt signal. INTRA is nothing but interrupt signal of port A. This interrupt signal given to the 8086 microprocessor. The meaning of that interrupt signal is port A having some data. Then 8086 understands data is with the port A register. I should read the data. Then fourth step, then immediately 8086 use its RD control signal, this one RD control signal, which is a low signal used to read data from the PA0 to PA7 bits. Now processor is start reading data from IO devices through the port A register. Data is read. In fifth step, once data reading completion, then RD signal, INTR signal, strobe signals, input buffer signals, all are going to be resetted for performing new operation. And one more important point here, before giving interrupt signal to the 8086 processor, now this is your interrupt signal, the 8255 must and should verify INTE A signal and port C signal both are connected or both are success or not. The meaning of INTE A is interrupt enable of port A, and strobe signal is acknowledged. Strobe signal is acknowledged. Both. Once interrupt is enabled, strobe signal is acknowledged. What is the meaning of it? Yes, strobe signal meaning given acknowledgement. Yes, interrupt signal is enabled. If both are okay, then only the interrupt signal is given to the 8086 microprocessor. Then normally processor use its read signal to read data from the IO devices to the 8086 processor. The above diagram shows the port A register data to be read by the 8086 processor. Same sequence of steps used in the below diagram. Here port B register used to read data from the input output device to the 8086 processor. Now see, in the above diagram we used port A register control word. Now see the control word D7 1 IO mode, D5 D6 01 mode 1, D4 1 decides the port A direction, and D3 port C direction. Now we already discussed this D4 D3 bits in the previous class. Same here, observe the control word for port B register D7 1 indicating IO mode, and D2 1 indicating here port B mode 1 operation, port B mode 1 operation, and D1 indicating port B and port C direction bits. But here we used only port B for transferring of data from IO device to the 8086 processor. Like this, using the control words, the 8086 microprocessor reads data from the IO devices through the port A or port B. Now these are the sequence of the steps what I explained in the previous diagram. So please go through step by step neatly. Then how 8086 processor will read data from the IO devices to the 8086 processor. These steps are for input operation, nothing but port A or port B used as input ports. Now see, in the next case, port A or port B using as output operation. Output means from the 8086 processor the data sent to the IO device. In previous example, the 8086 processor reads data from IO devices to the 8086 processor. That's why it is known as reading. Now in this example, the 8086 processor outputs the data or simply writes the data to the IO devices using port A or using port B. Now same steps, but here acknowledgement signals are differ. Now see, first one, the control word what we are using here. Now this is case for port A, this is case for port B. Now see, first one port A direction, then same procedure followed for port B. Now control word D7 1 indicating mode 1, D5 D6 01 indicating mode 1, nothing but strobe or handshaking signals. If you observe, strobe and handshaking signals are here interrupt signals, strobe signals, acknowledgement signals. Now see, D4 1 indicating port A, information, either input or output. Now one indicating output information, now D3 bit indicating port C direction. Now same sequence of steps followed before follow the sequence of steps. Now see here few terms. OBF, nothing but output buffer full, A, acknowledgement of port A. ACKA, acknowledgement signal port A. Interrupt signal port A. Now P6, P7, PC3, PC4, PC5 use as status and control signals. We already know port C bits used for control status signals, port A and port B used for data transmission signals. Now in the previous case, in previous example, port A or port B used only input operation. Now in this example we will see port A or port B used as output information. Now step 1, here output means first data to be placed in A register or B register. That's why first step the 8086 processor place the data on the port A register or port B register by giving first its address signals. Why? Because port A having some address, port B having some address. Using address signals, 8086 processor identify the port A address first or port B address first. After identifying the port A or port B address, then it places data on the data lines and immediately issues the WR signal enable. Now it is a low signal. Once port A address, port B address found, then data is placed on the data bus, then enables the WR signal, then writes data on the port A or port B. That's the first step. Now data is with the port A in this diagram, port B in this diagram. Once data is with the port A bits or port B bits, then second step the I255 will give a signal through the PC7 port C 7th bit, OBF, nothing but output buffer full, acknowledgement, output buffer full. The purpose of this output buffer full is the data with the port A register or data with the port B register. Once output buffer full is given, the data is started to sending to the output device. Once IO device takes the data, then immediately it will give one acknowledgement signal, ACKA, nothing but acknowledgement signal of port A, that will receiving by the port C 6 bit. The meaning of that signal is data received by the IO device. Then next third step, Once acknowledgement taken by the 8255 interface unit, then immediately it will give interrupt signal INTRA signal to the 8086 microprocessor. That interrupt signal indicating the IO device reads the data what 8086 processor sended. And next step, when INTRA signal is given to 8086 processor, now verify here. If it want to give interrupt acknowledgement, first INTE, nothing but interrupt enable a signal is enable, and PC6, nothing but acknowledgement signal is enable. Now what do you mean this? Interrupt is enable, acknowledgement enable, nothing but device is given acknowledgement, then immediately yes, processor is going to be interrupted. Once this interrupt acknowledgement is given, processor understands that data received by IO device, then I should start sending off new data on the ports. Like this, port A or port B used as only output transfer information. Previous case only input information, in this case only output information. Now see the below the control word D7 1 indicating IO mode. These all are not required, that's why all are given don't care. So because this is example for port B. Now port B D2 1 indicating mode 1, port B mode 1, and D1 indicating output signal. You please verify the control word format which we already discussed in previous classes. These are the sequence of steps used for only output information. First, processor only initiate data transmission by sending port address. Then after sending port address, it will issues write signal. After sending write signal, the 8255 enables it output buffer signal. Then after enabling that output buffer signal, the IO device reads and give its acknowledgement signal to the 8255. Once 8255 receive acknowledgement A signal, then it will informing to the 8086 processor through its INTR signal. Then after receiving interrupt signal, the processor is ready to send new data to the ports. Now see this diagram. IO mode 2 operation, nothing but IO mode 2, what we know? Yes, port A or port B bidirectional, not port B, port A used as bidirectional. Bidirectional means port A used only for input data, port A only used for output data. In previous two cases, port A use only input, port in second case port A use only output. But in third case, bidirectional indicating same port A used as input, same time port A only used as output. That's why it is known as bidirectional. Now see the control word first, D7 1 indicating IO mode operation. Now observe D6 D5 bits 1 and don't care. 1 and don't care means we already know 1 don't care, nothing but mode 2 operation. Mode 2 operation means the port A use as a bidirectional. Same time it can use for input data reading, same time it can use for output data sending. Now see the sequence of steps used by 8255 interface unit. Very simple, same as previous cases. First step, IO device place the data on the 8255 port A. Then second step, after placing IO device data on the port A, issues strobe signal A. Now that is receiving by port C4 pin. The meaning of strobe signal is nothing but giving acknowledgement to the 8255 port A register. I send data to your port PA0 to the PA7. Then immediately second step, the 8255 giving acknowledgement signal to the IO device, that is an input buffer full. The meaning of it, what data you received? Yes, I store data in my port A0 to the A7 bits. Then after receiving the input data, now data is with the port A register PA0 to the PA7 bits. Immediately it will give interrupt signal to the 8086 microprocessor. Now this is an interrupt signal giving from port A to the 8086 microprocessor. Now at that time processor issues RD signal, yeah, this one, which is a low signal used to read data from the port A bits or port A register. After performing input operation, now processor is going to be perform output operation. Now same given here, observe first 8086 processor place the address of the port A, then 8255 receives port A address, and second step, place the data on the data bus and enables the WR signal. To enable here, low signal required. After enabling WR signal, now data is with the port A bits, A0 to A7 bits. Then it will giving acknowledgement output buffer full, acknowledgement of port A, indicating the data is with the port A register. After receiving data from the 8086 processor, data is with the PA0 to PA7 bits. Then second step, after receiving output buffer signal, it will give data to the output device. After receiving data from the port A register, the IO device making acknowledgement to the 8255 port A register. Now first 8086 place the port A address and place the data and enables the WR signal. After enabling, data presented in the port A register, then immediately 8255 given output buffer signal to the IO device. Then IO device reads the data. After reads the data, it will give acknowledgement signal to the 8255 port A indicating data successfully received. Then immediately this will give interrupt signal to the 8086 processor for sending new data. Now observe in this case, same time port A used for input purpose by giving signals STBA, IBFA, nothing but strobe signal of port A, input buffer signal, input buffer full signal of port A. Same giving output signals, output buffer full signal of port A, acknowledgement signal of port A. Like this, at the same time in IO mode 2 operation, port A performs input as well as the output operation. Now once again observe the control word D7 1, D6 D5 1 don't care, mode 2, D2 port, group B, either port A or port B using for data transmission, but in the given example they are considered only port A for data transmission. So like this, same port A used for bidirectional, means it can send data from 8086 processor to IO device, IO device to 8086 processor through the port A. That's why port A known as bidirectional.